Good afternoon, everyone. Good afternoon. Good afternoon. Welcome back again to the NEET Elite. Hope all of you are doing great, guys. If I'm audible and visible to everyone, hit the chat box with the thumbs up. Let me know if I'm audible and visible to everyone fast. Let me know if I'm audible and visible to everyone with the thumbs ups in the chat box. Priya, I'm doing wonderful. Hi, Deepak. I'm doing great. How are you? Hi, Khushi. Hi, Janvi. Hi, Yashwant. Hi, Farooq. Hi, Azra. Hi, Sahana. How are you guys doing? How are you guys doing? Wonderful, guys. Great, great. Deepak, I'm good, bro. I'm good. Better than before. Yes. Walaikum salam, Babar. How are you doing? Hi, Christina. Guys, I cannot read all the names. I'm really sorry. So, welcome again to the NEET Elite. As you all must be knowing, today we are starting the next phase of this equilibrium, and till now we are done with the chemical equilibrium, and in today's session we are going to start the one more fascinating topics from the equilibrium, which is what we call as ionic equilibrium. Yes, ionic equilibrium we are starting, right? Hi Wahid, how are you? Hi Sneha. Okay. Thank you. Abila, thank you. Same to you. All right, so people, before starting the today's session, let me introduce myself. My name is Wassim and I'm your chemistry master teacher over here, right? As you all must be knowing, right? And before starting, do like, share and subscribe the channel so that everyone will get benefited out of these sessions, out of these lectures, okay? Now people, before starting the session, I'm going to give you the brief introduction, the brief description of the Vedantu NEET Pro Subscription, what all benefits you guys are going to get if you are enrolling yourself in any of the plans in this Pro Subscription. Let me tell you, you guys are going to get the 5,000 plus hours of live online teaching. Correct? Regular tests and assignments will be provided to you, which contains more than 10,000 questions. We have got 20 plus teachers with 5 plus years of experience will be constantly training you, personally helping you out for the upcoming NEET 2021 or NEET 2022. Yes, and let me tell you, you have got the complete liberty to learn either in English or in Hindi. The choice is completely yours. You can select the language, get trained personally by the master teachers of Vedantu in your physics, chemistry, as well as biology, right? And at the end, we are going to cover everything over here, which includes your micro as well as crash course, okay? For the ones who are going to appear in the NEET in 2021, we have come up with 3 different plans for you. And for every plan, we have got 20% off right here. The first plan, which is the 1 month plan, you guys are going to get it for 6K after the 20% off, yeah? And the 3-month plan, after the 20% off, you are getting it for 16.8K. 6-month plan, after the 20% off, you guys are going to get it for 31.2K. Yes, and all these plans are valid for the ones who are going to appear in the NEET in 2021. Now, for the people who are going to appear in the NEET in 2022, again, we have come up with 4 different plans for you guys as well. Let me tell you, the 1-month plan, after the 20% off, you guys are getting it for 4K. 3-month plan, you are getting it for 10.8. 6-month plan, you are getting it for 19.2. And 12-month plan, after the 20% off, you guys are getting just for 33.6K. Yes, okay. And for the droppers, we have got 3 plans as well. And on every plan, you have got 20% off. Again, the 1-month plan after the off is 7.2K. 3-month is 20.4. 6-month plan is 40.8K, right? And all these plans are valid for the droppers, and on every plan you have got again 20% off right here, okay? Now the point is how to enroll in these, how to get these plans, how to get enrolled in the actual Vedantu classrooms. Let me tell you guys, there's a link in the description box of the video. I want you guys to click on that link, use the coupon code as WSPRO. By using this coupon code of WSPRO, you guys are going to get the 20% off on whatever plan you're selecting for yourself. Yes? Okay. Afra is asking, Lee Chatelier principal lecture is not available. Yes, I took the lecture basically, but it was unavailable after some time. The reason was there was some technical glitch in between the video. So I will record that video again and I'll post it soon, okay? Alright guys, so are you super duper excited for the today's session? Let me know in the chat box fast. Let me know in the chat box if you guys are super duper excited for the session. Yes. Walaikum salam. Let me know in the chat box if you guys are super duper excited for the today's session. Let me know fast in the chat box. Give me the thumbs ups. Let me see the josh of the today's session as well, as we are starting with something new, yes, and interesting at the same time. Give me the thumbs ups in the chat box if you guys are super excited for the today's session. Yes, I can see a lot of thumbs ups are coming up. I can see a lot of thumbs ups are coming up. That's wonderful. That's great. That is great. That is great. That's great. Super duper excited. Josh is extremely high. That's wonderful. That's wonderful, guys. So without wasting a lot of time, let me start with the new topic, Ionic Equilibrium. Yes. So in the today's session, I'm going to give you the basics of this Ionic Equilibrium, which we'll be frequently using in the upcoming sessions of this Ionic Equilibrium. And these basics are really very important. And I want you guys to understand these basics properly, which I'll be teaching you in the today's session, because these are really important. Okay. Yes. All right. So let me start the today's discussion with the term called as electrolytes. What are electrolytes? What are electrolyte? All of you must have heard about the term electrolyte. Now the point is, what is that electrolyte? As per its definition is concerned, guys, electrolytes are the substances which on dissolving in water dissociate into their ions, right? Electrolytes are the substances which on dissolving into water dissociate into their ions, right? Those substances which on dissolving in water dissociate into their respective ions are what we call as electrolytes. Yes, those are what we call as electrolytes. Now people, we classify these electrolytes into two types. One is called as strong electrolyte, one is called as weak electrolyte. If you guys are, all of you must be knowing that. Yes. Let me first of all tell you, electrolytes are the substances which on dissolving in water dissociate into their ions. Yes, dissociate into their respective ions. Now let me tell you, the electrolytes are classified into two types. One is called as strong electrolyte, one is called as weak electrolyte, right? Now people, what are strong electrolytes and what are weak electrolytes? For that, let me show you the next slide. See guys, strong electrolytes are the ones which are completely ionized, which are completely dissociated in their respective ions in the aqueous solution. Yes, those substances which dissociate completely in their respective ions in the aqueous solution, those are what we call as strong electrolytes. So strong electrolytes are the ones which on dissolving in the aqueous solution, they break completely into their respective ions. As you can have a look on its definition, these are completely ionized, these are completely dissociated into their respective ions when we drop them into their aqueous solution. Yes, when we make the aqueous solution of them. Very simple. Now, what are the examples of these strong electrolytes? Remember guys, all your strong acids, strong bases and water soluble salts, these are the examples of these strong electrolytes, right? All your strong acids, all your strong bases, all your water soluble salts, they are the examples of the strong electrolytes. They get completely dissociated into their respective ions when we make the aqueous solution of them. Yes, very simple terminologies. All of you must be knowing this. Yes, for example, if I'll give you certain examples of the strong acids are your HCl, it's a strong acid. H2SO4, it's a strong acid. Yes, strong base, all of you must be knowing, NaOH is your strong base. Yes, all your strong acids, strong bases and water soluble salts, they get completely dissociated into their respective ions, and any substances which completely get dissociated, which completely get ionized into their respective ions in the aqueous solution, those are what we call as strong electrolytes. Yes, so remember from now onwards, all your strong acids, all your strong bases and all your water soluble salts are the examples of the strong electrolytes which completely get dissociated into their respective ions in their aqueous solutions. Yes. Now people, one more thing. If you'll take the general salts of alkali metals, what are alkali metals? Your lithium, sodium, potassium, rubidium, cesium, these are what we call as alkali metals. Yes. when you will take the general salts of these alkali metals. For example, if I take NaCl, this is the one general salt of these alkali metals. General salts of these alkali metals, they are considered as the strong electrolytes. They are considered as the strong electrolytes, which are water soluble, Yes. So your general salts of alkali metals, when you will make their aqueous solution, they completely get dissociated into their ions. Absolutely. Okay, so they are the examples of the strong electrolytes. If you will take the salts of this NH4 positive, ammonium, right? If you will take its general salts, for example, if I'll take ammonium chloride, NH4Cl, this is the salt of this ammonium ion. Yes, NH4Cl. Correct? Similarly, if I'll take ammonium nitrate, NH4NO3, right? Ammonium bromide, anything. If you'll take the general salts of this NH4 positive, all those salts are again water soluble, which on dropping into water dissociate completely into their respective ions. Yes, and at the same time, if you'll take the salts of this nitrate ion, for example, I have got sodium nitrate, potassium nitrate, and so on. All those salts again are the water soluble salts, and all the water soluble salts are considered as the strong electrolytes, which completely break down into their ions. So in short, I want you guys to remember, strong electrolytes are the substances which get completely dissociated, completely ionized in their respective ions in the aqueous solution. Okay, examples of strong electrolytes are the strong acids, strong bases, and water soluble salts, right? These are the examples of the strong electrolytes which completely get dissociated, which completely get ionized into their respective ions. Yes, absolutely. Okay, and at the same time, if you'll take the general salts of alkali metals or NH4 positive salts or NO3 negative salts, those are again the water soluble salts which completely get dissociated into their respective ions in the aqueous solution. Yes, so remember all this, guys. This is all basics which you must know before starting the chapter. Okay, at the same time, what are weak electrolytes? Weak electrolytes are the ones which are not completely dissociated into their ions, right? I would say weak electrolytes are the ones which are partially ionized in their respective ions in the aqueous solutions. Okay, weak electrolytes are the ones which do not get completely dissociated into the ions. Yes, which do not get completely dissociated into the ions in their aqueous solution, right? What are the examples of these weak electrolytes? If you'll take weak acids, if you'll take weak bases, weak acids and weak bases are the common examples of the weak electrolytes. Okay, they do not get completely dissociated into their respective ions, which you need to remember. For example, if I'll take a weak acid as CH3COOH, it is the example of the weak acid. Weak base, for example, I'm taking NH4OH. This is the example of weak base. All your weak acids, all your weak bases, they are the examples of the weak electrolytes which do not get completely dissociated into their ions in the aqueous solutions. Yes, very, very, very simple. Okay. Now, people, at the same time, all your sparingly soluble salts are the ones which do not get completely dissolved in water. Yes, sparingly soluble salts are the ones which are not completely dissolved, which are partially dissolved, okay? And all your sparingly soluble salts are again the examples of the weak electrolytes which do not get completely dissociated into their ions. Yes, so remember it at the same time. You have got certain examples of the sparingly soluble salts as well. AgCl, PbCl2, Ag2Cl2, Ag2SO4. These are all the examples of the sparingly soluble salts which are not 100% dissolved in the water. Yes, so I would say all your weak acids, all your weak bases, and all your sparingly soluble salts are the examples of the weak electrolytes which do not get completely dissociated into their ions, which are partially dissociated, Yes. Okay, guys, this was something basics. At the same time, remember, for the strong electrolytes, alpha value is always taken as 1. Alpha value is always equal to 1 for strong electrolytes. For strong electrolytes, we always take alpha value as 1 because strong electrolytes are completely dissociated into their ions, right? Their degree of ionization, this alpha over here represent degree of ionization, correct? In the chemical equilibrium, we used to call this alpha as degree of dissociation, but in this chapter, we'll be calling it as degree of ionization. It is just the terminologies are different, but the meaning is same. Whatever was your degree of dissociation, same is your degree of ionization over here in this chapter. Yes, and in case of weak electrolytes, let me tell you the value of alpha is greater than 0, less than 1. The value of alpha for the weak electrolytes, I'm writing it over here, for the weak electrolytes will lie between 0 and 1. Okay, so remember, degree of ionization of the weak electrolytes lie between 0 and 1. But in case of strong electrolytes, the value of alpha will be equal to 1. Okay, this was something basics which I wanted you guys to remember before starting everything. Okay, let me summarize it. Electrolytes are the ones which are dissociated into their ions in their aqueous solutions. Okay, we have got two types of electrolytes: strong, weak. Strong electrolyte is the one which gets 100% dissociates, which gets 100% ionized into its aqueous solution. Yes, alpha value for a strong electrolyte will be 1. Correct? All your strong acids, strong bases and water soluble salts, these are the examples of the strong electrolytes which get completely dissociated, which get completely ionized in their respective ions, okay, in their aqueous solution. At the same time, let me talk about the weak electrolytes as well. Weak electrolytes are the ones which are not completely ionized, which are not completely dissociated into their respective ions and aqueous solutions. Okay, and at the same time, all your weak acids, all your weak bases and all your sparingly soluble salts, these are the examples of the weak electrolytes, right? Let me know in the chat box if it's clear to you. Let me know in the chat box if it's clear to you, so that I can move ahead and talk about few important things right here. Let me know first in the chat box if everything is clear till here or not. Yes, Ayan. Yes, exactly. You have to study it for boards as well. Yes, yes, absolutely. Let me know in the chat box if it is clear, so that I can move ahead and talk about the actual stuff. Yes, exactly. This was very easy, right? Now we are moving to the actual topic which we have to discuss in the today's session. Okay, understand, guys. First of all, let me write a statement over here, and I want you guys to note this statement with me. Weak electrolyte does not get completely dissociated into its respective ions in the aqueous solution. So your weak electrolyte always remains in equilibrium with its ions. Weak electrolyte always remains in equilibrium, Weak electrolyte always remains in equilibrium with its respective ions. In the aqueous solution. Okay, this is something which I want you guys to remember. Okay, just note this down. This is very important. Remember, whenever I'll be talking about the weak electrolyte, understand that weak electrolyte will be in equilibrium with its ions, right? With its respective ions in the aqueous solution. Correct? Now, people, let's understand few basic and important things which are really very important. See, guys. First of all, I'm right now talking about the ionization constant of the weak electrolyte. So first of all, this is one electrolyte which I've taken right here, and I'm considering this electrolyte to be a weak electrolyte. This is the weak electrolyte. If it is a weak electrolyte, then definitely it will be in equilibrium with its ions, and these are the ions of this electrolyte in the aqueous solution. Yes, and this electrolyte and its ions are in equilibrium with each other. Very simple. Now, people, if you remember, whatever treatment we used to do with the moles, the same treatment over here in this chapter we are going to do with the concentration. What is that? If you remember, in your chemical equilibrium, I used to write at time t is equal to 0. Let's say I have got A moles of this, I have got 0 moles of this, I have got 0 moles of this at time t is equal to 0. If the degree of dissociation is alpha, I used to write it as A minus A alpha. I used to write this as A alpha. I used to write this as A alpha, right? This is something which we used to do in chemical equilibrium. Yes. In the ionic equilibrium, we'll be directly dealing with the concentration. We are not going to deal with the moles over here. We'll be directly dealing with the concentration. And we are going to deal with the concentration in the same way as we used to do with the moles. What does that mean? Understand that. Understand that. See, guys. See, first of all. At time t is equal to 0, when the reaction has not started, Okay, let's say the concentration of this electrolyte is C. Let's say the concentration of this electrolyte is C. Let's assume degree of ionization of this electrolyte is alpha. Degree of ionization of this electrolyte is alpha. Degree of ionization as well as degree of dissociation, they are same. It is just the terminology is different right here. Meaning is same. Okay. Let's say degree of ionization right here is alpha. So first of all, at time t is equal to 0, there will be 0 concentration of A positive, there will be 0 concentration of B negative at the same time. Yes. Now people, at equilibrium, I will be left with C minus C alpha concentration of AB. The concentration of A positive at equilibrium will be simply C alpha and this will be C alpha. Yes. Yes, the treatment I used to do with the moles, I'm doing the same treatment with the concentration directly over here. Correct? Let's say the initial concentration of the electrolyte was C. It was 0. It was 0. Now, what will be the concentration of this electrolyte left at equilibrium? It will be simply C minus C alpha. Correct? What about the concentration of A positive? It will be C alpha. What about concentration of B negative? It will be C alpha. Yes? Now, people, one more thing. If I'll have electrolyte like this, AB2. Let's say I've got weak electrolyte AB2, okay? If it is a weak electrolyte, it will be definitely in equilibrium with its ions. And what are its ions? Its ions are A di positive aqueous plus twice B negative aqueous plus twice B negative aqueous. These are the ions of this electrolyte. Yes. Now people, if the concentration of this AB2 at time t is equal to 0 is C, this is going to be 0, this is going to be 0. Let's say the degree of ionization is alpha. So at equilibrium, I would say the concentration of AB2 will be C minus C alpha. Now what will be the concentration of A di positive? Simple, use the mole concept. 1 mole gives 1 mole. So C alpha should give me C alpha over here. So this C alpha is the concentration of A di positive at equilibrium. Now again, if 1 mole gives 2 moles, let's say 1 mole gives 2 moles, yes? Let's say 1 mole gives 2 moles from the stoichiometry. 1 mole gives 2 moles. So C alpha moles should give me 2 times C alpha over here. So this 2 C alpha is the concentration of B negative at equilibrium. Yes, very, very simple. Very, very simple, yes. Let me know in the chat box if it's clear. Let me know in the chat box if it's clear. Let me know in the chat box if it's clear. Fast, fast, fast. Who is saying it wrong? Yes? Maybe, bro, you are right. Let me know in the chat box if it's clear, guys. Fast, fast, fast. Now, guys, understand one more thing. Understand one more thing. See, I'm taking my general weak electrolyte as AB aqueous, right? This is the concentration of AB electrolyte at equilibrium. This is the concentration of A positive at equilibrium. This is the concentration of B negative at equilibrium, right? Now, people, how we used to write the expression for equilibrium constant, do you remember that? How we used to write the expression for equilibrium constant, if you remember? I used to write the expression for equilibrium constant as concentration of A positive to the power 1 multiplied by concentration of B negative to the power 1 divided by concentration of AB over here to the power 1. This is how we used to write the expression for equilibrium constant in terms of concentration. Yes. Now people, that equilibrium constant over here, I'll be calling it as the ionization constant. I'll be calling it as the ionization constant. Basically, this ionization constant, it is same. It is the same equilibrium constant. But over here, the terminologies are different. Instead of equilibrium constant, I call it as the ionization constant. Very, very, very simple. Yes. Now people, the concentration of A positive at equilibrium is C alpha. The concentration of B negative at equilibrium is C alpha divided by concentration of AB at equilibrium is C minus C alpha. Yes. So I can write ionization constant, which is actually equilibrium constant. Yes. This will be equal. This will be equal. This will be C square alpha square divided by C square alpha square divided by C. I'll take common. This will be 1 minus alpha. So 1C and 1C got cancelled. So I got C alpha square divided by 1 minus alpha. This is the expression for the ionization constant of the weak electrolyte. You are not supposed to remember this expression. You should know how to make this expression, how to form this constant expression. Yes? Only thing which you need to remember, in the chemical equilibrium, we were dealing with moles. Now, in this chapter, we are going to directly deal with the concentration. The treatment which we used to do with the moles, the same treatment we are going to do over here with the concentration. That's it. That's it. Yes, that's it. That's it. Yes? Yes, guys? Let me know in the chat box if it's clear. Operational team, can you block this user, this LAIQID? He's writing something, I mean, I don't know. Block this guy. Okay, this is the expression for ionization constant. Yes? You're not supposed to remember this. Again, I'm telling you, you're not supposed to remember this. You should know how to write this expression. That's it. Yes? Number 1. Number 2, guys. Number 2. Number 2. Number 2. This is a simple question. This is a simple question over here which you guys are supposed to solve. Okay? This is a very simple question. One thing you need to remember. One thing you need to remember. What is that? Have a look. See, guys, understand properly. This is basically Ki. This is written like this, Ki. This is not Ki, potassium iodide, okay? This is not potassium iodide, this is Ki. Ionization constant, okay? Have a look on the question, guys. Calculate the concentration of each species at equilibrium for 0.1 molar solution of weak electrolyte AB, okay? If, case number 1, if degree of, if dissociation constant is equal to 10 power minus 5, case number 2, if dissociation constant is equal to 10 power minus 2. You need to remember few things right here. You need to remember few things right here, okay? See, guys. I have got the weak electrolyte as AB. I'm taking the electrolyte as AB aqueous right here. This is given in the equation that is a weak electrolyte. It is a weak electrolyte. If it is a weak electrolyte, it will stay in equilibrium with its ions in the aqueous solution. Yes. So its ions are going to be A positive aqueous plus B negative aqueous. Yes. This is something which we know. This is something which we know. Now, people, understand one important thing. Understand one important thing. See, guys. Calculate the concentration of each species at equilibrium. We have to calculate the concentration of each species at equilibrium for 0.1 molar solution of weak electrolyte. So, basically, we have got 0.1 molar of this weak electrolyte. Yes, we have got 0.1 molar of it. Now, people, I'm writing at time t is equal to 0. At time t is equal to 0. Let's assume the concentration of AB electrolyte is C. This is going to be 0. This is going to be 0 at time t is equal to 0. If the degree of ionization is alpha, at equilibrium, can I say the concentration is going to be C minus C alpha? Right? Can I say at equilibrium the concentration of A positive is going to be C alpha and the concentration of B negative is going to be C alpha? Yes? Now, people, if I'll write the expression for dissociation constant, how will I be doing that? I'll be simply writing concentration of A positive to the power 1 multiplied by concentration of B negative to the power 1 divided by concentration of AB. Yes. Now, concentration of A positive at equilibrium is C alpha. Concentration of B negative at equilibrium is C alpha. Concentration of AB at equilibrium is C minus C alpha. Yes. So, I'll get C square alpha square, and in the denominator, if I'll take C as common, it's going to be 1 minus alpha. 1C will get cancelled out. So it becomes C alpha square divided by 1 minus alpha. Correct? This is something which I got. This is something which I got. Now, people, understand important things which you need to remember from now onwards. Okay? Understand that. I got the Ki value, ionization constant, expression as C alpha square divided by 1 minus alpha. This is something which I got till now. Yes? Now, people, see. Now, I'm going to solve the question. I'm going to solve the equation, the first one, in which ionization constant value is given as 10 power minus 1, right? In the first question, the value of ionization constant is given as how much? It's given as 10 power minus 5. Yes, and we know the concentration. We know the concentration of the electrolyte, which is given to us as 0.1 molar. Which is given to us as 0.1 molar. This is something given to us. Yes. Yes. Now people, if you remember, I told you in the weak electrolyte, alpha value lies between 0 and 1. Alpha value lies between 0 and 1. Yes, the value of alpha lies between 0 and 1. Now people, remember one important thing. Remember one important thing from now onwards. If I'll be having a weak electrolyte, okay? For example, if for the weak electrolyte, alpha value is less or equal to 0.05. If alpha value is less or equal to 0.05, at that time, I can easily neglect alpha. I can easily neglect alpha, okay? Remember, whenever you see alpha value less than 0.05, or in general, I'll say, whenever you will say alpha value is far less than 1, at that time, I can neglect alpha. But remember, if the value of alpha is greater than 0.05, and less than 1, I cannot neglect alpha. I cannot neglect alpha. I cannot neglect alpha. Now, what does that mean? What does that mean? See guys, understand over here. Understand over here. What am I supposed to calculate? I'm supposed to calculate the concentration of each species at equilibrium. Yes, I'm supposed to calculate concentration of each species at equilibrium. Now, right now, I have no idea whether to neglect alpha or not. I have no idea whether to neglect alpha or not. Yes. So what I'll be doing is I'll be assuming certain things. I'll say let the value of alpha is far less than 1. Let the value of alpha is far less than 1. If the value of alpha is far less than 1, I can neglect alpha at that time. I'm assuming let alpha value is far less than 1. If the value of alpha is far less than 1, I can write the expression as Ki is equal to C alpha square divided by. If value of alpha is far less than 1, that means if the value of alpha is less or equal to 0.05, then instead of 1 minus alpha, I can only write 1. I can neglect this alpha. So I'll get the value of alpha from here as under root of Ki divided by C. Under root of Ki divided by C. What is the value of Ki which is given to me right now? The value of Ki which is given to me right now is 10 power minus 5 divided by C is the concentration of electrolyte, which is how much? C is the concentration of electrolyte, which is 0.1. So you will be getting the value as 10 power minus 2. From here, this is 10 power minus 10, this is 10 power minus 5, it becomes 10 power minus 4. Root of 10 power minus 4 is 10 power minus 2. So the value of alpha which I got right here is 0.01. It's coming as 0.01. Now people, is 0.01 less than it or greater than it? 0.01 is less than this value, less than 0.05. So whatever assumption we have done, that is correct. So whatever assumption we have done, that is correct. Okay, we actually got alpha value is less than 0.05. Alpha value is far less than 1. Alpha value is far less than 1. So whatever assumption we have done, that is correct. Yes? Correct? So we got the alpha value as 0.01 or 10 power minus 2. We got the alpha value. Let me write it over here. We got the alpha value. Just a second. We got the alpha value, how much? 10 power minus 2. Yes. Now people, I'm almost done. I'm almost done. What was I supposed to calculate? What was I supposed to calculate? Just a second. What was I supposed to calculate? Calculate the concentration of each species at equilibrium. If you remember, I had the electrolyte like this, AB aqueous. It was in equilibrium with its ions. Its ions were A positive aqueous plus B negative aqueous. Yes. A positive aqueous and B negative aqueous. At equilibrium, if you remember, the concentration of this one at equilibrium was C minus C alpha. The concentration of A positive at equilibrium was C alpha. The concentration of B negative at equilibrium was C alpha. Yes. 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 Now guys, I can simply do what I was supposed to calculate. Concentration of A positive is equal to what? C alpha. Do we know the C value? Yes, 0.1. Do we know the alpha value? Yes, 10 power minus 2. The value will be simply 10 power minus 3. So 10 power minus 3 is the concentration of A positive at equilibrium. Absolutely. Can we simply calculate the concentration of B negative? It's again C alpha, so its value will be again 10 power minus 3 molar. Yes. What will be the concentration of this electrolyte left at equilibrium? It's going to be C minus C alpha. Simple. I'll write concentration of AB at equilibrium is C multiplied by 1 minus alpha. Yes. Or you can write C minus C alpha, one and the same thing. C value we already know, that is 0.1. 1 minus alpha value we got to know as 0.01. Yes, just calculate this value, you'll get the concentration of AB as well. Let me know in the chat box if it's clear to you. Let me know in the chat box if it's clear to you. Wonderful, guys. Let me know. Give me the thumbs ups in the chat box so that I can move on, and talk about few more fascinating things right here. Let me know in the chat box fast. Yes. Yes. Wonderful. Wonderful, guys. So remember, whenever you see alpha value as less or equal to 0.05, we have to neglect alpha at that time. Okay, we can neglect alpha at that time. So keep this in mind. Now, the second part of the question, guys, the second part of the question, understand that as well. The second part of the question. Since we know the electrolyte was AB aqueous, getting dissociated into A positive aqueous plus B negative aqueous. Yes, its concentration initially was C, this was 0, this was 0. Now, if the degree of ionization is alpha, at equilibrium, the concentration of electrolyte AB is C minus C alpha, this is C alpha, this is C alpha, right? If you remember, Ki expression we used to write as C alpha square divided by 1 minus alpha, if you remember. Yes, this was the ionization constant. Yes. Now, guys, understand one thing. Now, in the second part of the equation, Ki is given as 10 power minus 2. Right? So Ki to me over here in the second question is given as 10 power minus 2. Correct? And what we have to calculate? We have to calculate concentration of each species at equilibrium. Yes? So what I'll be doing? Ki value is 10 power minus 2. C value, concentration of electrolyte, is given to me as 0.1 molar. It is given to me as 0.1 molar. Yes? Now we will see. First of all, I have no idea whether the alpha value I have to neglect or not. So what I'll be doing? I'll be assuming, let the alpha value is far less than 1. And after using that statement, I'll get the actual value of alpha. If the actual value of alpha was coming as far less than 1, that means my neglection was correct at that time. Yes? How? See, guys. See. First of all, Ki value over here is 10 power minus 2 is equal to C value is 0.1, C value is 0.1, alpha square divided by 1 minus alpha. Now I'm assuming if alpha value is far less than 1, if alpha value is less than 0.05, so what can I do at that time? I can neglect this alpha in front of 1. So what I'll be getting? I'll be simply getting the answer as 10 power minus 2 is equal to 0.1 multiplied by alpha square. Yes, I've neglected this alpha in comparison with 1. Correct? So can I get the value of alpha square, or I can get the value of alpha as under root of 10 power minus 2 divided by 10 power minus 1. Yes. So 10 power minus 2 in the denominator you have got 10 power minus 1. So it will be coming as 10 power minus 1. So alpha value actually I'm getting as 1 divided by root 10. Yes. 1 by root 10 value. 1 divided by root 10 value is almost equal to 3.14. So it will be alpha value will be almost equal to 0.3. Alpha value will be almost equal to 0.3. But people, is the value of alpha coming as greater than 0.05 or less than 0.05? It is coming greater than as 0.05. That means whatever my neglection was, that is wrong. I cannot neglect alpha now. Yes. So what I'm going to do now? I have to solve the quadratic equation. Okay. And how will I be solving quadratic equation? Since I got to know alpha value is not coming as less than 0.05. So my neglection was wrong. So what I'll be doing now, just have a look. So first thing which I got to know, I cannot neglect the alpha value. So what to do? There is nothing, there is no option left, guys. I have to use normally the quadratic equation. I have to solve the quadratic equation. See how? Ki value, it is 10 power minus 2 is equal. 10 power minus 2 is equal. C value, it is 0.1. Right? Alpha square as such divided by 1 minus alpha. Divided by 1 minus alpha. Now people, 10 power minus 2. That means 1 by 100. 0.1, 1 by 10. So on the left hand side, it becomes 1 divided by 10 is equal to alpha square divided by 1 minus alpha. Yes. So I got the quadratic equation as 10 alpha square plus alpha minus 1 is equal to 0. This is the quadratic equation which I got. This is the quadratic equation I got. Yes. Yes. Simple. 10 power minus 2. That means 1 by 100. This 0.1, 1 by 10, x 0 cancel. So on the left hand side, I got 1 by 10. On the right hand side, I got alpha square divided by 1 minus alpha. Just do the cross multiplication. This is going to be 1 minus alpha is equal to 10 alpha square. So 10 alpha square plus alpha minus 1 is equal to 0. I got the quadratic equation. Now people, you already know how to take the roots of the quadratic equation, right? I'll simply write alpha is equal to minus b plus minus under root of b square minus 4ac divided by 2a. This is something which we do. But in your NEET, they'll never ask a question in which you have to solve a quadratic equation. Okay? In your NEET, you always will be neglecting alpha. They'll always deliberately give you a question in which alpha value will be less than 0.05. So at that time, you directly have to neglect that alpha. Okay? But by chance, if the alpha value was coming as greater than 0.05, at that time we have to get the quadratic equation like this. We have to get the roots of the quadratic equation, and after getting the roots, we'll be getting the value of alpha. Yes? Exactly, Karthik. It will take time to solve. Exactly. They never ask these questions in your NEET. Yes? Got it? I hope you got the clear-cut idea of what to do and what not to do. Yes, absolutely, guys. I'm moving on, and let me talk about few more interesting things and important things at the same time. Okay. Ionization constant of weak acid. Ionization constant of weak acid is represented by Ka, and ionization constant for weak base is represented by Kb. Okay. Ionization constant for weak acid is represented by Ka, and ionization constant for weak base is represented by Kb. Okay, what is this ionization constant for weak acid? It's a basically equilibrium constant, right? But over here terminologies are used different. Actually, it is equilibrium constant. Yes, actually Ka and Kb, these are the equilibrium constants. But over here terminologies are, kept different. Yes. See, guys. For example, I have got a weak acid Ha. Understand properly. This is Ha. This is a weak acid. So it will be in equilibrium with its ions, and its ions are H positive aqueous plus A negative aqueous. Yes. H positive aqueous plus A negative aqueous. Let's say the degree of ionization is alpha. Let's say the degree of ionization for this weak acid is alpha. So at time t is equal to 0, I'm assuming the concentration of Ha is C. This is 0. This is 0. So at equilibrium, guys, this is going to be C minus C alpha. This will be C alpha. This will be C alpha. Yes. Now, how do I write the expression for Ka? What is Ka? Ka is the ionization constant for the weak acid, right? Ionization constant for the weak acid. Yes. It is same. Its expression is same as that of equilibrium constant. It is basically equilibrium constant, right? But the terminology is used different right here. It's just the terminologies are different. Meaning is same. I'll write the expression for K in the same way I used to write the expression for equilibrium constant. It's going to be concentration of H positive to the power 1 multiplied by concentration of A negative to the power 1 divided by concentration of HA. Yes, it's going to be again equal to C alpha square divided by 1 minus alpha. This is how I'll be writing the expression for ionization constant of the weak acid Ka. Yes. Similarly, if I'll be having a weak base, weak base I'm taking as BOH aqueous. If I'll have the weak base is the example of weak electrolyte, so it will be in equilibrium with its ions. Yes. So BOH and its ions are going to be B positive aqueous and OH negative aqueous. Yes. Now people, if the degree of ionization is alpha, if the degree of ionization of this weak acid is alpha, again the same procedure I'll be doing. At time t is equal to 0, the concentration of BOH is C. This is 0. This is 0. So at equilibrium, it's going to be C minus C alpha. This is going to be C alpha. This is going to be C alpha. Now, since it is a base, so I cannot write Ka. I can write Kb, where Kb is the ionization constant for the weak base. Yes. And I'll write the expression in the same way I used to do for equilibrium. Yes. I'll simply write concentration of what? Concentration of B positive to the power stoichiometry coefficient multiplied by concentration of OH negative to the power stoichiometry coefficient divided by concentration of BOH. And all these concentrations of these ions and BOH are taken at equilibrium. Yes. So I'll be writing it again. It will be C alpha square divided by 1 minus alpha. So this is again the value of Kb. This again the value of ionization constant for the weak base. Now people understand, more the value of Ka for the acid, more will be the strength of the acid. Remember this at the same time. Note. More the value of Ka for the acid, more will be the strength of the acid. Similarly, more the value of Kb for the acid, more will be the strength of the, more the value of Kb for a base, more will be the strength of a base. Yes? Yes, remember this at the same time. More Ka means more acidic strength for the same concentrations. What does that mean? You'll get that idea when I'll be giving you some questions, okay? Remember right here, more the Ka value for the acid, more will be its strength. More the Kb value for the base, more will be the strength of the base. Remember it at the same time. Yes? Let me know in the chat box if it's clear to you first. Let me know in the chat box if it's clear to you so that I can give you a lot of questions on this so that your concepts will get clear properly. Let me know in the chat box fast. Let me know in the chat box fast. Wonderful guys, great. Let's move on then, let's move on. I hope this is clear. See, the question says, calculate the H positive concentration. Calculate the H positive concentration of 0.05 molar CH3COH solution. You are given with the ionization constant of acid as well. Okay, you have to calculate the concentration of H positive. Very simple question it is. Yes, very simple question it is. See guys, I'm given with on weak acid. Weak acid is CH3COH. It will be definitely in equilibrium with its ions. Its ions are CH3CO negative aqueous plus H positive aqueous. These are the ions of this weak acid. Correct? These are the ions of this weak acid. If the degree of ionization is alpha, at time t is equal to 0, the concentration of this is going to be C. It is going to be 0. It is going to be 0. Yes? Now people, at equilibrium, the concentration of CH3COH will be simply C minus C alpha. This will be C alpha. This will be C alpha. Right? What are we supposed to calculate? Calculate the H positive concentration. H positive concentration at equilibrium we got to know as C alpha. So basically I'm supposed to calculate the value of C alpha. Yes? That will give me the H positive concentration. Now how do I do that? How do I do that? That is the point. Yes? First of all, if I'll write the expression for Ka right here, ionization constant of the weak acid. How do I write the expression? I'll be simply writing concentration of CH3CO negative multiplied by concentration of H positive divided by concentration of CH3COOH aqueous. Yes, it's going to be equal to concentration of CH3CO negative. It is C alpha. Concentration of H positive. It is C alpha divided by concentration of CH3COH. That is C minus C alpha. So you'll get it as C alpha square divided by 1 minus alpha. Yes, this is something which you are getting, correct? So Ka value you got as C alpha square divided by 1 minus alpha. Now the point is, do I have to neglect alpha or not? Do I have to neglect alpha or not? If the value of alpha will be less than 0.05, then I have to neglect alpha. Yes? Yes? So I'm assuming if alpha value is far less than 1, I can neglect alpha at that time. So instead of 1 minus alpha, I can only write 1. So people, alpha value at that time will be simply equal to under root of Ka divided by C, right? Under root of Ka value is given to me as 1.25 into 10 to the power minus 6 divided by C. C is the concentration of electrolyte. C is the concentration of electrolyte, which is 0.05. Yes, which is 0.05, absolutely. Very simple. Now people, how do I solve it further? See, this is 1.25, this is 0.025, this will be 1 zar, this will be 25 times. Yes, it's going to be 25 times. So 25 multiplied by 10 power minus 6. So it's going to be simply 5 into 10 power minus 3. 5 into 10 power minus 3. So I got the value of alpha is 0.005, which is actually very, very less than 0.05. Yes. So whatever neglection I have done, it is correct. I got the alpha value. I got the alpha value, 5 into 10 power minus 3. People, if I got the alpha value, I can easily calculate the concentration of H positive over here. Yes, I can write the concentration of H positive as C alpha. C value, how much is it? C value is the concentration of electrolyte, which is 0.05 multiplied by alpha value I got to know as 5 into 10 power minus 3. Just calculate it, you'll get the concentration of H positive over here. Yes. Yes. Let me know in the chat box fast. Let me know in the chat box fast if it's clear to you. Let me know in the chat box fast if it's clear to you. Yes. Exactly, Yashwant. Alpha value is 0.05. Sorry, 0.005, which is actually less than 0.05. Yeah. So whatever neglection we have done, that is correct. Yeah, clear to everyone? Wonderful. Let me move on to one more then. Let me move on to one more. Let me move on to one more. This is the last question which we'll be doing, okay? And in the upcoming session, this was all about basics of ionic equilibrium, guys. I hope you have, got everything of the basics of the ionic equilibrium. And in the next session of the ionic equilibrium, we'll be solving the, we'll be starting the actual ionic equilibrium. This is just the basics which you should know before starting, okay? Right? Okay. The question is, calculate the ionization constant of a weak base, NH4OH. If the concentration of OH negative ions in its 0.1 molar aqueous solution is 0.05. So I am given with the concentration of OH negative ions at equilibrium. How much it is? I am given with the concentration of OH negative ions at equilibrium. It is 0.05. I am given with the concentration of aqueous solution of NH4OH, right? I am given with the value of C. Concentration of NH4OH initially it is 0.1 molar. This is something which is given to me. What am I supposed to calculate? What am I supposed to calculate? Calculate the ionization constant of weak base. We are supposed to calculate the value of Kb. Yes? Yes? See guys, first thing, your NH4OH, as you all must be knowing now, it is a weak base. If it is a weak base, it will remain in equilibrium with its ions, and its ions are NH4 positive aqueous plus OH negative aqueous. Yes, I can say that. I can say that. At time t is equal to 0, the concentration of NH4OH is C. This is going to be 0. This is going to be 0. Let's say degree of ionization is alpha. Let's say degree of ionization is alpha. So at equilibrium, I'll be left with C minus C alpha, concentration of NH4OH. The concentration of NH4 positive at equilibrium is simply going to be C alpha. This will be simply C alpha. Right? What is this C alpha over here? This is the concentration of OH negative at equilibrium. Yes? This is the concentration of OH negative at equilibrium. And if you know the concentration of OH negative at equilibrium, it is given to me in the question as how much? 0.05. Right? This is something which is given to me. This is something which is given to me. Yes? Now people, can I calculate alpha value from here? Alpha value from here will be 0.05 divided by C. C value is how much? C value is given to me as 0.1. C value is given to me as 0.1. Yes? So what will be the value coming? Value will be 0.5. Value will be 0.5. Correct? Value will be 0.5. Alpha value is coming as 0.5. Am I supposed to neglect alpha now? Tell me. Am I supposed to neglect alpha? Let me know in the chat box fast. Am I supposed to neglect alpha? I cannot neglect the alpha, right? Because if the value of alpha will be less or equal to 0.05, then only I can neglect alpha. But over here, alpha is 0.5, which is greater than 0.05. So I cannot neglect it. Yes, I cannot neglect it. So what I'll be doing? I'll be simply writing the dissociation constant of this weak base will be equal to concentration of NH4 positive raised power stoichiometry coefficient multiplied by concentration of OH negative raised power stoichiometry coefficient divided by concentration of NH4OH. Yes, this will be equal. This will be equal. Concentration of NH4 positive at equilibrium, that is C alpha. So this is at the end you will get it as C alpha square divided by 1 minus alpha, if you remember. Yes, I cannot neglect alpha value right now, so I have to put the alpha value. So Kb I'll be getting as C alpha square. What is the value of C? C value is 0.1. 0.1 means 10 power minus 1. Alpha square. Alpha is 0.5. So this is 0.5 ka square divided by 1 minus alpha. 1 minus 0.5. Using this equation, you'll get the value of Kb from here. Yes, which is what we were supposed to calculate. Calculate the ionization constant of the weak base. This is the ionization constant of weak base, right? Right? Sadia is saying it's coming as 0.05. Khushi is saying 0.05. All right, I'm going with you. It's coming as 0.05. Yes, this is the value of ionization constant for this weak base, which we were supposed to calculate. Absolutely. Absolutely. Yes. So people, this was all for today. Okay. In the next session, let me tell you, we are going to do the common ion effect. In the next session, we'll be doing the common ion effect. Actually, I thought of starting the common ion effect today only. I thought of finishing it off, but I won't be able to finish it off in like 5 minutes because we have got a lot of problems to do in this effect. So I'll be teaching this common ion effect in day after tomorrow session. Okay. Tomorrow is the session on mole concept. Do not miss that all. Okay. Do not miss that at all, guys. Okay. Tomorrow is the session on mole concept, in which I'll be doing some great problems from the chapter mole concept. Okay. And day after tomorrow, we'll start from this topic, which is your common ion effect. Correct? I hope you have enjoyed this session. I'll see you guys again tomorrow at 3 p.m. Okay. And tomorrow we are going to do some miscellaneous problems from the chapter mole concept. So guys, Karthik, today there is no homework, bro. there is no homework. Brent is asking, what time is it in India? In India, it is almost 4. Alright guys, I'll see you guys tomorrow now. Till then, you guys take care. Bye-bye. God bless you all and love you all. See you tomorrow at 3 p.m. again on NEET Elite. Take care till now. Till then, okay. Bye-bye. God bless you. Take care.